4.2 logarithmic functions. All right, this again is another section where the notes, that PDF notes that are online might have more than we're actually going to go over in this section. I did that for previous classes, for my classes at the high school level where I have a little bit more time just to go over into some more advanced stuff for some of the graphing, but we don't need to know that for that's not in the curriculum for Holmes. Okay. All right, so logarithmic functions are the inverse operations, the inverse functions of exponentials. Okay, meaning they go the opposite way. All right, now some basics of the log. You have a base, which is in subscript, and then you have the argument or the input of the log, which is in the inside, and we have that number here. Okay, the number to the inside has to be bigger than 0, and then the base has to be bigger than 0, and it can't be 1. All right, so that you can notice that maybe from section 1 you might remember that the base of an exponential function has to be bigger than 0 and can't be 1. Same thing for the base of the log. All right, and so it's basically writing the exponential backwards. Okay, you can see down here, exponential form, we have a base to an exponent is equal to a number. And here we have the log with the base of a number is our exponent. Okay, and we'll see these as examples in a second, but let's do something like this. If I said 5 to the second power is 25, that would be an exponential form. And in log form, we have the exponent 2 is equal to log base 5 of 25. Okay, so basically we have the difference between the two. We do have the word log here, which is short for logarithm. All right, but the base goes down here in the subscript after the log, and then the exponent and then the answer to the exponential switch places. Okay, here the exponent is on part of the work we're having to do, and then we have our answer. Where over here the answer is inside the log, and the exponent is over there by itself. All right, let's look at some examples. All right, changing from logarithmic to exponential form. All right, so if this is a logarithm, which it is, to write it in exponential form, we're going to look at the base first. The number is in subscript, so my base is going to be 5. All right, your base is here. All right, the answer to a logarithm is the exponent. So your exponent is the one that's over by itself. So 5 to the second power. And then your answer is what you have inside here. Okay, we're going to call that the argument. All right, so 5 squared is equal to x. That's how I would write that as the exponential. All right, let's do this one. Same thing. I look at the base. The base is b. All right, here's your base. All right, your exponent is the number by itself. So b to the third is equal to, and then our answer or our argument is over here, so 64. All right, c is written where the equal sign or the log is on the opposite side of the equal sign, but it's the same thing. We have our base is the numbers in the subscript. We have our exponent that's by itself on the other side of the equal. And that's equal to what's inside the log. So 3 to the y is equal to 7 is the exponential form of log base 3 of 7 is equal to y. All right, so pause this, try these checkpoints, and see if you can get them right. All right, here are the answers. I've got 7 to the third is equal to x. I've got b to the second is equal to 25. I've got 4 to the y is equal to 26. All right. All right, example 2, we're going to go the opposite way around. We're going to take the exponential and rewrite it as a log. All right, so we're going to write log. All right, and then we're going to find our base, which is the big number of the exponent part, the power. So log base 12. All right, and then we over here on its own is the argument. That's going to go inside the log. So it's a log base 12 of x. And our answer to the log is the exponent. So 2. So base, then we get the number by itself, argument, and then the answer is the exponent. So on B, we have a log. The base is B. It's the base of the exponential. All right, we put the number that's by itself inside the log. It's called the argument of it. And then we're going to be equal to the exponent. All right, and C, we have that E that we saw in that last section. So the log base E. We'll learn a different way to write that later. All right, the argument is the number that's by itself over here, so log base E of 9. And then our answer is the exponent, y. All right, give it a break or give it a pause and see, try these checkpoints. All right, here are the answers. I've got log base 2 of x is equal to 5. Base, and then we go hit the argument, and then end with the exponent. All right, the next one's log base b of 27 is equal to 3. Start at the base, get the answer, go back and hit the exponent. All right, then for C, I've got log base E of 33 is equal to y. Start with a base, get the answer to the exponential, and then the answer to the logarithm is the exponent. All right. Now evaluating logs. Okay. Some of the other sections are going to show some other way to evaluate these properties of logarithms, which we'll learn. All right, but to start off with, we got to remember that the answer to a logarithm is an exponent. Okay, the answer to the logarithm is an exponent. The answer to a logarithm is an exponent. All right, so when we look at logarithms, we can say, hey, what number do I need to raise the base to? Okay, so 2 to what power gives me 16? Okay, you don't have to write it down like this, but what you're thinking is 2 to what power is equal to 16? All right, so you might start thinking about it. All right, well, I know 2 squared, 2 times 2 is 4. I know 2 to the third, 2 times 2 times 2 is 8. And 2 to the fourth is 16. Okay, so the answer here is I need to raise 2 to the fourth power in order to get 16. So the answer here is 4. Okay, we're keeping in mind that if we were to write this as an exponential, we're saying 2 to the answer power is equal to 16. So we're looking for that exponent. All right, B. I've got 7 to what power, which is our answer, is equal to 1 over 49. All right, well, if it was just 49, we would definitely know our answer is 2, because 7 squared is 2, or 7 squared, excuse me, is 49. All right, but the 49 is on the bottom, but if we remember from exponents, a negative exponent moves it to the bottom. So we know that 7 to the negative 2 power is the same thing as 1 over 7 squared, which is 1 over 49. Okay, so if you have a fraction where you have a 1 on top, and then a number on bottom that is a power of the base, then put a negative exponent. All right, for C, a little tricky here. We have 25 to what power is equal to 5? All right, so here the number inside the argument is a smaller number than the base. Okay, and so we can think about, well, if it was opposite, if the 5 was the base and the 25 was the argument, I know 5 squared is equal to 25. All right, but it's backwards. So we got to think about, hey, I know the square root of 25 is 5. All right, but we've talked about it. The square root is the same thing as saying to the 1/2 power. Okay, so the square root of 25, since that's 5, and that's the same thing as saying 25 to the 1/2 power, that's our answer is going to be 1/2. Okay, so if the argument is the square root or the cube root of the base, then we have 1 over whatever the square would be 2, cube root would be 3. All right, and then D, a little difficult here. We got 2 to what power gives me the 5th root of 2. All right, but it's the same kind of argument we had on C. All right, I could rewrite the 5th root of 2 as 2 to the 1/5 power. Whatever that index of the root is, that goes in the bottom of a 1 over that number power. So the answer here is 1/5. Because I got 2 to what power gives me this? Well, that's 2 to the 1/5. So the answer is 1/5. All right, now these are a little more difficult. Pause it, and then we'll look at the answers of the checkpoint. All right, the answer to A is going to be 2. Because I know 10 to the 2nd power is equal to 100. All right, for B, my answer is going to be a -3. All right, because 5 times 5 is 25, times another 5 is 125. And since 125 is on the bottom of a fraction, I got to put a negative up there. All right, for C, my answer is going to be 1/2, because I know the square root of 36, or I know 36 to the 1/2 power, which is another way of writing square root, is 6. And then for D, my answer is 1 over 7. Because inside here, 3/2 though, we can rewrite the 7th root as 3 to the 1 over 7 power. All right, some basic logarithmic properties. Okay. If the base and the argument are the same, then the answer is 1. Okay? Because b to what power gives me b back again? The log of 5, log base 5 of 5, what do I need to raise 5 to in order to give me 5? The answer is 1. All right? And then if you have 1 as your argument, no matter what the base is, your answer is going to be 0. Okay, because when we're saying b to what power gives me 1, and we learned with exponents, anything raised to the 0th power gives me 1. So if the base and the argument are the same on A, which they are, my answer is 1. All right, if the argument is 1, my answer is 0. All right, so look at that checkpoint. If the base and the argument are the same, the answer is 1. If the argument is 1, the answer is 0. Okay, if the base and the argument are same, answer is 1. If the argument, the inside of it, is 1, the answer is 0. All right, kind of using those properties. All right, we talk about the fact that the exponential and the logarithmic are inverses. Okay, so on this one, if you have the base and the argument are the same, but the argument is raised to a power, you can basically just cancel out the logarithm and the base, excuse me, of the inside, and your answer is just going to be the number on the inside. Okay? They undo each other. So the base, if you see the argument, has the same base as the base, but it's raised to a power, you can ignore everything else except for the power, and that's your answer. Okay? If you have it written the other way, where you have an exponential, like here we have on B, we have 6 raised to the, and then the exponent is a log with the same base as the base of my power. Those can cancel out, and the answer is just going to be what's left over. Okay? So again, if you see this situation where either you have a log, and the argument of the log is an exponential, but the base is the same base as the log, they cancel out, and that exponent's the answer. If you have an exponential where the exponent is a log, and the base of the log is the same as the base of my exponent, or exponential, then the inside of the log is the answer. All right, so pause it, try checkpoint. All right, here you go. Log base 7 of 7 to the 8th. The log base 7 and the 7 to the cancel out. My answer is 8. For B, I've got 3 to the log base 3 of 17. So 3 and the log base 3 cancel out, and my answer is just 17. All right. And then finally, before we finish the lesson out, there's 2 types of logs that will pop up that are very prevalent in word problems and in real life. We have the common log and we have the natural log. Okay? And the common log is the log that has a base of 10. Okay, so if we have a log base 10, let's say, we'll just put a variable here, x. Since the base 10 pops up a whole lot in math, because our number system is a base 10 system, okay, we count by tens and hundreds and thousands as our place values. All right, then if we have that, a lot of times we'll just see it written as a log with no base. It's called our common log. So if you don't have a base written there, it's understood to be 10. So here are the general properties with common logs. Okay, if you have a log of 1, again the argument's 1, so its answer is 0. If you have a log of 10 and you don't see a base, since the understood base is 10 in the common log, those match up and my answer is 1. All right, if you have the log and then you have 10 to the x, again, since the base is 10, the log and the 10 cancel out, the answer is the x. Or if you have 10 to the common log, those cancel out and get x. So if you don't see a base, it's understood to be 10. All right, and then our other type of logarithm that pops up a lot is the natural log. Okay? And that is a log with a base of e. All right, we saw some of those on our previous examples. So we see the log base e of x. You probably won't see that a whole lot because we rewrite that as the natural log, ln. Okay, and I just usually do my L in cursive because if not, it looks like it's 1 n. Okay, so this is the natural log of x. So if you see ln, the base is an understood e. All right, again, that pops up a good bit in those growth models. You can also see it in financing, financial statements. All right, and so we have some of those same properties out here. All right, good luck working on MATLAB. If you got questions, again, send me an email.